Hi, this is Yogesh Tandge, and in this video, we will see the numerical which is asked in the GATE examination 2023. Let's see the statement of it. What is the statement? A perfectly insulated concentric tube, a counter current heat exchanger, is used to cool a lubricating oil using the water as a coolant. Oil enters the outer annulus at a mass flow rate of 2 kg per second with a temperature of 100 degrees Celsius and leaves at 40 degrees Celsius. Water enters the inner tube at a mass flow rate of 1 kg per second with a temperature of 20 degrees Celsius and leaves at 80 degrees Celsius. Use the specific heat of oil and water as 2089 joule per kg per Kelvin and 4178 joule per kg per Kelvin respectively. There is no phase change in both the streams. Under the steady state conditions, the number of transfer unit that we need to find out. So here we need to find out this, what is NTU value. The diagram is given here. So it gives the oil which is entered from the annulus one on this side with a temperature 100 degrees Celsius and 40 degrees Celsius, and water is entered in this one with inner 20 and outer 80. So let's see how to solve this one and to know what is the value of this NTU one. So this diagram, it shows that we write, say, from the annulus oil is flowing, so we can say that the oil is enter here. Okay, so what is the temperature is mentioned here 100 degrees Celsius, and it leaves from here, and the temperature it's of 40 degrees Celsius. So there is exchange of it between the water, and water is flowing inner side with inner temperature is 20 degrees Celsius, and it leaves water at 80 degree Celsius. Okay, so here we can say that is water is flowing inner side and the oil is flowing outer side, and there is an exchange of heat between these two. And the question is asked, what is NTU for this case? So let's see that the conditions are mentioned that NTU that we need to find out. And for that one, we first write down the formula for it. Okay. So what is the formula for the NTU? General formula for the NTU, we can have NTU is equals to the U, orally transfer coefficient, into the surface area upon the C minimum. So what is the C minimum? C minimum we can calculate with the help of the formula. Okay, that C minimum is equals to the what? We can write a mass flow rate and the specific heat of the things. So first we will write a data which is mentioned here, and then we will solve that numerical how we can do that one. So what are the data is mentioned? The data is given here. It is, so two data is mentioned. The one is the water, that is fluid which is flowing inner. Okay, so we write the first data of water. So we write the mass flow rate which is mentioned. So mass flow rate of water which is 1 kg per second. Then the T in for water which is 20 degrees Celsius. So in input 20 degrees Celsius, and T out for the water one which is 80 degree Celsius, and mention the CP value. What is the CP value? The specific heat of water which is given 4178 joule per kg per Kelvin. Similarly, the data for the oil which is flow through annulus. Okay, and we are writing the same thing, the mass flow rate for the oil which is 2 kg per second, Then the T in for the oil, which is 100 degrees Celsius, and T out, that is temperature of outlet temperature of oil, which is it is 40 degree Celsius, and also the specific heat is mentioned. Specific heat of oil, which is 2089 joule per kg per Kelvin. Okay, so we have this data, and with the help of this data, we would like to calculate what is the value of NTU. So let's see how to do that one. The first we will write the formula for it. So what is the formula for the NTU? The formula for the NTU, it is NTU, that is number of transfer unit, is equals to the overall heat transfer coefficient into the space surface area upon a C minimum. So let's focus one by one. If I know the value of U, if I know the value of A, and if I know the value of C minimum, I can get the NTU. But in our conditions, they only mention the data, mass flow rate, and four temperatures and the specific heat. So on the basis of that one, we would like to calculate this one. So let's first, it is possible for us to calculate C minimum. So what is the value of C minimum? So we can write that is the formula for C minimum. It is, say, the specific heat of, say, mass flow rate of water into the specific of water, and mass flow rate of oil into the specific heat of the oil. So whichever be the less, that is the C minimum. Okay, either this one or this one. So let's do the calculation for this one. So I can write for the, as we have the mass flow rate and the specific heat, so we will calculate that C minimum. So let's see, for the C minimum we can write C minimum is equals to the, say, for consideration, mass flow rate of the water and specific heat of the water. So mass flow rate of the water is 1 and specific heat of the water is 4178. So answer is 4178. Similarly, I try to do it for the another case, say for the oil. So I can write a mass flow rate of oil into the specific heat of oil. So what is the mass flow rate of the oil? Say mass flow rate of the oil is mentioned here. It is 2 into the specific heat of oil is given 2089. So when I multiply it again, my answer is 4178. So in the both the cases, if I see the value is same. So either you take this one or this one, doesn't matter because the C minimum is the same one. So we got a value of C minimum, which is 4178. Okay, so this is the first case. Okay, now, so this C minimum we calculate. Now we will focus on this one. As for the U, I need inside transfer coefficient and outside transfer coefficient. And for the surface area, at least I should know what is the diameter and the length of the exchanger. The both the things are missing. So let's see how we can calculate this UA. So to calculate the UA, we have a simple formula. So general formula we will write. So what is the general formula for the U? So we can write the Q is equals to the U into the surface area, that is UA, into delta TL. Now in this case, if you look this formula, then I know the value of Q from the energy balance equation, that is M into Cp into delta T. Okay. I also calculate the delta TLM with the help of the formula, that is delta T1 minus delta T2 upon ln of delta T1 by delta T2. So with the help of this formula, I can calculate. So now the case is Q, I can calculate M either you take the mass flow rate of the oil and specific heat of the oil and the temperature difference, or we can take for the water as we found the same value of it. So let's Q. If I want to calculate the Q, then I can write, say, for the in terms of, if I say for the oil, if I want to calculate in terms of oil, then I can write a mass flow rate of the oil into specific heat of the oil and the temperature difference of it. So what is the temperature difference? It is 100 inside and out is 20. Okay. If I want to write in terms of water, then I can write a mass flow rate of water into specific heat of water and the temperature difference of it. And the temperature difference is what? It is 80 minus 20. So sorry, here is 40. Okay. Now, if I put it these values for the oil, if I put the oil is 2 into the specific heat of it, 2089, into the difference, if I say the difference of it, then 100 minus 40 is 60. And similarly, if I, this is for oil, and now if I want to calculate for water, then again I can write a mass flow rate of the water into the specific heat of the water, okay, into the temperature difference, and temperature difference is 80, 20 is 60. So if I do the calculations, then again I got the same value of Q. So here I'm not interested to calculate the value of Q, because again I can write in terms of water. So I just 1 into 4178 into the 60. So that will be the value of Q. Okay. So I just, rather than I'm calculating this one, I just put it as it is, because later on I will tell you why I'm doing this one. Okay. So value of Q that we got, this one. So this is another answer for me. Now I'm concentrating on delta T1, delta TLM. How we calculate delta TLM? Again, we can write formula for the delta TLM, which is already be written. So we can say that delta TLM is equals to the delta T1 minus delta T2 upon ln of delta T1 by delta T2. Now in this case, simply we can write that it is a co-current one. So I can just write this way, and okay, so these two lines. So this is shows, say, for the oil, enter at 100 degrees Celsius and leave at 20 degrees Celsius, and for the water it is 20 degrees Celsius and out is 80 degrees Celsius. Sorry, this is 41. Okay, just one mistake is here. We just correct that. Okay, so wrongly I just put it that temperatures. So let's do it again. So the water enter at 20 degrees Celsius and leave at 80 degrees Celsius. Okay, and the oil which is enter at 100 degrees Celsius and it is leave at 50 degree Celsius. So this is the way that we can just write down that formulas and all. Now So if we see the difference of these two, so difference between this one and this one, then you will find it is the same one as 40 minus 20. So delta T1 is 20. Similarly, our delta T2 value from here, if I want to calculate delta T2, then again I found it is 20. Now if I put it these values, delta T1 and delta T2 here, then the value is 0. But whenever such a cases arise that when the temperature difference at initial and at a length L, if it is the same, then we can say if the both the end temperatures difference same, then in this case we can write it is assume that across the length temperature difference remain constant. So throughout this one I say a temperature remains constant, which is 20 degrees Celsius, and in this case we take a LMTD is not required. So in situation like this one we do not require this LMTD calculations, and here we assume the LMTD is as constant term whatever it is. So here in this case it is a 20. So LMTD value we consider the 20. Why? Because the both the case the difference is same, so it is obviously it is 0. In such a situations we consider throughout this case the value throughout this one we say it is a 20 degree. Okay, so constant term, so we take the average value is 21. Okay, so as we calculate now, again just look this formula, I just back it. Okay, so we have this formula. Okay, this formula with this, so we calculate this value, and from that one I can easily get this term. Okay, so now I just put in that values and I get an answer of it. So I just put in that value in the equation. I again write this equation UA delta T LM. So value of Q is I'm writing it is 1 the mass flow rate of the water into the specific heat of water, and the temperature difference is 60 is equals to the UA, which I want to find out, and delta TLM value is 20. So from this one I can easily write down, therefore I can write UA is equals to the 4178 into 60 divided by 20. So I am not calculating the value of UA. Okay, though the value of UA if you calculate then it is 125340, but now we just put this value only. Okay, I will tell you why, so that we can save the time. Now let's remind that the NTU equation. What is the NTU? We write the NTU is equals to the UA divided by C minimum. Now what is the value of UA? So we have the value of UA is 4178 into the 60, okay, upon 20 into what is the value of C minimum? The C minimum value is again this right formula for C minimum is what? A mass flow rate into the specific heat. At the both the cases the value is same, so I just consider the water one. So mass flow rate of water is 1 into the specific heat of the water, which is 4178. Okay, and now the values is here. Now I just write without a calculator, we can just calculate, because that's why we are not find the value of put in the value of UA, which is this one. Okay, so we just cut these two. Okay, and when we divide the 60 by 220, it is 60. Okay, so we can say that the value of NTU is 3. Okay, so by this way we can easily solve, and just I say that Why I'm not calculating these values? It is just because that I want to just cut it in that way. Otherwise, if I calculate, then I need a calculator and extra time just use on that one. Instead of, we can save the time by just doing this way. So this is the way that we can get a value of NTU, which is 3. So the answer is 3 in this situation. Thank you very much.